Hi all, welcome to our series of videos on BioRT HBV model. I am Kailvili Sadayappan or Kayal. Over the next few videos, I will be sharing some basic information about BioRT HBV model, like how to install the model, how to create input files, and how to run the model. In this video, I am going to talk about the data needed for running BioRT HBV model, as well as some potential sources where you may find them. Before running BioRT HBV model, we need to run HBV light model. HBV light model needs meteorological variables including precipitation, average temperature, and potential evapotranspiration as drivers. Precipitation and potential evapotranspiration should have units of mm per unit time, whereas average temperature should be in the units of degrees Celsius. Precipitation and temperature data are easily available from weather stations like those maintained under Automated Surface Observing Systems Network. Potential evapotranspiration data, however, are harder to come by, and often we have to use equations like Penman-Monteith equation, Priestley-Taylor equation, or Hargreaves-Samani equation to calculate potential evapotranspiration. Nowadays, R packages are available, allowing us to easily calculate potential evapotranspiration, provided we have enough meteorological data like solar intensity, temperature, relative humidity, etc. In case you can't find any weather station near your catchment, or you have several catchments and you need to extract meteorological information for all of them, then it is best to go for a gridded data source. Some of the major gridded data sources are DayMet, ERA5, NLDAS, and GLDAS. Next, we can also use precipitation chemistry data as a driving variable for the BioRT model. This is only an optional input data, because not many agencies collect precipitation chemistry data. If you're lucky enough to be near a site that measures precipitation chemistry, then you can always use this data also as a driver for the BioRT model. Precipitation chemistry data should be in the units of moles per liter. Some of the major networks that measure precipitation chemistry include NADP in America, EMEP in Europe, and EANET in Asia. Till now, we have been looking at data that is needed for running the BioRT HBV model as they work as the drivers. Now, we will look at data that is required for model calibration and validation. For the hydrology model HBV light, we need streamflow data for its calibration and validation. Streamflow data should be in the units of mm per unit time. Usually, streamflow data are measured in units of volume per unit time. However, for HBV light, this streamflow should be area normalized and the unit must be converted to mm per unit time. Coming to the BioRT component of the model, it requires water chemistry for model calibration and validation. Water chemistry data should be in the units of moles per liter, and all types of water chemistry data, including soil water chemistry, groundwater chemistry, and stream water chemistry, can be used for calibrating and validating BioRT HBV model. USGS is a good source of both streamflow as well as water chemistry data. In addition, the Critical Zone Network and Long-Term Ecological Research Site Network may also have the streamflow and water chemistry data for catchments across US. To summarize, we saw what are the data needed for running BioRT HBV model in this video. And these data are precipitation, average temperature, potential evapotranspiration, precipitation chemistry, and stream flow and water chemistry data. Thank you.